I am demonstrating project on IoT-based smart shoes for the visual impaired to make it easier for them to navigate around known and unknown places both indoors and outdoors. An estimated 285 million people worldwide are visually impaired. 1% of the population is blind in the world, and 10% from that fully blind. As per the given statistic, it is of the major importance to consider the problems the visually impaired are facing. We are crossing many streets together. Those intersections may be the most complex. Before making a turn, we should have to prepare. Normally, people are finding new paths using Google Maps or reading the road naming boards, or they can ask to get help from others. Another thing is they can avoid barriers easily without getting into accidents. But how fully blind people are facing this matter? Before implementation, I made a lot of reviews to analyze existing systems. Last year, 10th of October, Google introduced Voice Guidance Google Map. This solution supports only outdoor places, but this is not supported to identify the turning when it's meet the barriers. And the next system what I mentioned is the Sonic Guide. It is head-mounted wearable device that use a camera to take pictures for analyzing of the images using image processing. It is a heavy wearable device and the camera is always operated. It consumes electricity for that reason. SmartGain is another system. That device was made to help blind people to identify the barriers and notify them to the user via beep sounds. This is not supporting the guidance. User needs to make a decision when to turn when the barriers detect. Blind person can get help from dogs to navigate, but it is very expensive to train dogs. I proposed an IoT-based prototype wearable device and a system to guide the blind person to reach the destination from another place. Right hand side showing the rich picture of the proposed solution. This project has a device, mobile application and the cloud server. All the controls can be done via the voice commands and using the volume controls. Therefore, both indoor and outdoor navigation was made available from this one system. Another main feature of this system is its ability to notify users about barriers detected by using the speed of the user as a considerable factor. The fast-walking ones can be notified earlier in order to prevent them from facing any accidents. Another important thing is all the decisions turning coordinates the location which found the obstacles. All the data will be stored in the cloud storage against the route ID. To increase the accuracy of this system, datasets will be important to train this device. Arduino scripts and Java language used to write unique algorithms. If this is an outdoor location, the destination and route details are identified using the Google Maps. Based on this information, the mobile app decides to identify the curves in the road. Those points are shown in blue in the image on the right side. The next step is to find the nearest point and the distance to that point. Once arrived at this point, the next nearest point will be detected. Reach the destination, this scenario is done continuously and repeated until it meets the destination. When the user comes back and meets the previous points again, the app will be identified as the nearest point. This scenario will be executed when the destination is in an outdoor place. Where do you want to go? I want to go bus stop. Location found. Location name is bus stop. You have to go approximately 731 meters to meet the destination. Do you want to continue? Yes, continue. Okay, let's go. Two steps, turn right. Barrier in 3 steps. 1 steps, turn left. Turn left. Once turn very slightly to 1 steps, turn left. Turn right. 2 steps, turn right. 2 steps, turn right. Turn left. Barrier in 4 steps.
Barrier in 2 steps, turn right. Turn right. You reach the home gate.
I hope this project will benefit the visually impaired as most of the missing features in the current system are included.